For the next talk, we shift a little bit the focus and we look at some other domain related to security. So our next speaker will be Imtiaz Karim, who is assistant professor in the Department of Computer Science at the University of Texas at Dallas. And his research interests lie in the general area of system and network security, and more specifically, the focus is on security and privacy of wireless communication protocols, so here 4G and 5G, but also others such as Wi-Fi and Bluetooth, and to develop tools that systematically analyze real-world systems and widely used protocols using AI, but also using formal verification, program analysis, and software testing techniques. So, in this spirit now, the next talk, Gotta Detect Them All, Fake Base Station and Multi-Step Attack Detection in Cellular Networks. Thank you.
Yeah, thank you for the time. So actually, I'm going to talk about something different compared to all the other talks. So I'm going to talk about attacks and defenses. So jumping to that. So we have smartphones that connect to base stations, but there are devices that are called fake base stations, false base stations, stingrays, IMZ catchers. There are a lot of different names. So that can actually connect to the real world devices, bypassing the legitimate base stations and create different forms of attacks. So essentially the question is, are we connecting to the legitimate base station or not? So yes, we have security on top in layer 3, but still there are devices that connects to even today's network, 4G and 5G network. And not only that, using these devices, we can do a bunch of different multi-step attacks that has a lot of different implications, such as location tracking, privacy issues, denial of service. So essentially, there are a lot of different problems associated with these devices. So what we are trying to do is come up with an approach so that we can detect these sort of problems and solve that somehow. So just some motivation. So looking into different attacks that have been done using these sort of devices, I have a bunch of them up here. So the recent one that I found is last week. So last week there were these IMZ catchers or SMS blaster attacks in different countries. Even last month in the UN General Council, there were people who were trying to do some sort of attacks, and Secret Service caught a lot of them. So just to highlight how prevalent these sort of attacks are. So essentially, this is not something new. So we have fake base stations, false base stations from 3G, 4G. Even in 5G, they are still valid. We have billions of unprotected devices that are still vulnerable to this sort of attacks. And what we found out is existing approaches for this sort of attack detection require extra hardware. They are quite expensive. So overall, we aim to solve this problem to design something that can that people can use to detect these sort of threats on their phone. So we had few goals on what sort of solution we want to design. So first one, we wanted to design something that protects all the existing devices and hardware. We wanted something that requires no protocol change, so it's readily deployable, that requires no additional hardware, it has minimal overhead, and lastly, it supports roaming. So essentially, even if you move, you should be able to protect your devices. So all in all, the approach that we thought is, yes, we can deploy some sort of a machine learning solution to detect these sort of threats and mitigate them somehow. But this direction also comes with different problems. So I'll talk about how we solve some of those problems to realize this solution. So the first big problem is that we don't have any data set. So we cannot just deploy fake base stations in the wild. It's illegal. What we can do is deploy these sort of devices in small labs, but still that is not a large scale enough data set that we can train machine learning models on. So on that note, I think what we did was quite interesting in the sense that NSF has this sort of large-scale platforms, power platforms. One of them was Powder. So people use these platforms for different use cases, but no one used that for security purposes. So actually, we thought, why don't we deploy these attacks in Power platform? It's not illegal if they help us. So actually, we reached out to the Powder team and said that, guys, we want to do this attack, will you help us? They said, yes, it will be a bit complicated since they have to dedicate part of their network for us. But at the end, we were successful. So this is kind of a interesting use case that we can do security research using these large-scale platforms and create data sets for attacks and defenses that is not usually possible for us. So in this Powder platform, we actually created a data set that includes mobility. We kind of tried different form of attacks with different attacker levels, from less sophisticated to more sophisticated. And we deployed different multi-step attacks, and at the end created a large enough data set that we can train these models on. Now, moving on to the second problem. So essentially, yes, we created a data set, but another interesting thing for us, we figured out that existing models do not work that well for this problem. Then we started digging, and we figured out the root cause is the packets are exactly the same. So we cannot figure out whether a trace is from a real base station or a fake base station, because fake base station essentially can mimic everything, right? So that led us to create a different form of model. So we created a new model that combines both packet level classification and a trace level classification. So essentially, for the packet level classification, our approach is to combine stateful LSTM with attention. So actually what we saw, that statefulness models long-term dependencies, and attention focuses on the specific part of the packet that is malicious. So by combining this, we were able to create a model that detects fake base station better than the original models or available models that are to us. And for the next part, actually, we take this label data set from our previous model, and we figure out whether they are fake base station or legitimate base station. So going back to some of the discussion in the morning, that yes, we need AI for different things, but domain expertise is also really important, because with domain understanding, we can create different complex models that normal models usually are not able to achieve this sort of performance. In this case, the big problem that we are having is false positives. So if we have a lot of false positives, then this model or solution is kind of unusable. So with this model, we are able to detect fake base stations, but we also want to detect multi-step attacks, right? So basically attacks that has multiple steps. So for that, again, we figured out that fake base station detection model doesn't work well. So we created a multi-step attack detection pipeline using graph neural networks. So in that case, we have the packets, we create a flow graph, and deploy different graph neural network models to be able to detect what sort of specific multi-step attack it is. Just showing a small example. So here we have the normal 4G handshaking. We have some fake base station that comes in. And after that, we are able to do some sort of an attack that creates a denial of service. So essentially what we do, we take the packets and create a graph out of that. And from that graph, we figure out what specific type of multi-step attack it is. So essentially showing that deploying AI is also not easy. We have to figure out different models with different use cases to actually solve the problem. So overall, we created a solution where we created data generation, then move on to detect multi-step attack and fake base stations in real-world scenarios. So we did bunch of different validations. So in our case, we were able to achieve 96% accuracy with around 3% false positive. And we also did other validations because remember, we are trying to deploy this on the device. So we did some validation on power consumption, memory, time consumption. We also deployed it in different scenarios to figure out whether we are able to detect fake base stations or not. Lastly, we did more validation on unseen attacks and reshaped attacks. So for unseen attacks, here you see that none of the attacks go into the benign category. They might be misclassified, but you should be able to detect them. For reshaped attack, everyone fall into the same category. So basically, we are able to detect attacks, even attackers try to reshape them. Lastly, I have a small demo showing how we detect this. So essentially, we have a phone that is connected to network. We have this USRP, which we have created a fake base station with. After the attack is done, we turn on our solution. It goes through a bunch of steps. Hopefully, it will be able to detect. Yes, it is able to detect there is a fake base station. So we created this app for users to use, essentially so that we can deploy this solution. But there is a caveat, right? Because if you want to use this app, then you will have to root your phone. So this is something that I am happy to say that we got a research award recently to deploy this solution for users where they don't have to root their phone. Also trying to come up with some sort of a similar solution for core networks as well so that they are able to detect this sort of a threat. So as a takeaway, I would say that since we are talking about 6G and next generation of networks, it will be really good if we are able to solve this problem or the root cause of this problem, so we don't have these sort of threats anymore. So yeah, with that, I will stop the talk. Thank you. If you have any questions.
Is it on? Great presentation, thank you. I was wondering what you used for your fake base station, because different base stations may appear differently to your model. So how did you make that, or is it already existing?
So your question is that how we created fake base stations, right? So there are some existing papers and some like even industry research as well on the capabilities of fake base stations. So actually we look into all of them and design different categories of fake base stations. So I would say the naive ones just give the highest signal so your phone connects. But the more sophisticated one, so we talked into some industry providers who design fake base stations, mostly for law enforcement, not for illegal use. So they have some initial phase where they look into what are the existing parameters of the network. They try to mimic all those stuff. So that is our most sophisticated fake base station that we deploy. So in the data set, you will find all spectrum, right? You will have the most sophisticated one and the least sophisticated one as well.
Thanks.
Thanks a lot, Imtiaz. Thanks a lot. Once more.